Hello all, my name is Liviu. I've been an OpenSIPS developer for 3 years now, and it's just wonderful to see all of you here. In the next hour and a half, I will be talking about how we can do asynchronous operations in the new OpenSIPS and some fraud detection heuristics. So without further ado, let's start things off with a small icebreaker, and let's do a simple async stuff. So great. So, what, as we can see, asynchronous refers to nothing more than having jobs run in the background while your processes or active workers are simply able to keep working and process incoming traffic. In OpenSIPS, we allow you to trigger such functions using a dedicated script statement. And I'm going to go a bit over the implementation details and what are the requirements for future functions to be able to be implemented in the asynchronous mode. For example, well, I can definitely tell you that not all libraries have support for asynchronous operations. We managed to do it with MySQL, but it's not officially documented. It's sort of a side effect, yet it works pretty well. PostgreSQL, on the other hand, they fully support and allow you to pull the file descriptors and call on them. Whereas with different database engines such as MongoDB, the guys, if you ask them about async, they will just say, just use thread pooling techniques and worry about async like in 10 years from now, I don't know. So what is it? So how exactly does it work? Firstly, we need some sort of a Unix file descriptor, which we can throw into the reactor. This can be a simple socket or a standard output file descriptor of, let's say, an external process. Say we fork an shell script. How we implemented it into OpenSIPS, we simply came to the conclusion that we just cannot isolate it without going at SIP level. So, because you'd have to save the context, right? And if you do not connect it with the transaction, when resuming, things are going to be quite rough because there are all sorts of retransmission problems and whatnot. Thus, whenever you do an async call in the script, you will break the script and trigger your prepare your query to be resumed for later. The following is an illustration of how radically different the model is. In up to 1.11 OpenSIPS, one process that would have to be doing blocking operations would simply spend most of its time blocking and merely waiting for the operation to complete. You can see the blocking operations being sequentially run and the worker basically doing not much. Whereas in the async model, it is continuously able to just run job after job after job and throw all the descriptors into the reactor, and whenever there is an event pending, run the resume route. So this will have the immediate effect of dramatically improving the scalability capabilities of the script, which perform blocking operations, of course. Some of you might simply not use a costly call for each incoming invite. But for those of you who do perform such operations, the async functions will make much better use of the system resources, and you won't need to fork so many children to handle all the jobs. The slightly disadvantages of using, but this is a lot said, are the complicated type of logic that will ensue, because we have to do this suspend resume type of logic in the script, and maybe not all of you, or not even us, were comfortable doing it at first. The thing with the library limitations, since most of them don't recommend, don't mention, and don't support such behavior, way of usage. I will be showcasing an example of simply what it meant to how a scenario looked up to far, and how it will look when switching to the async code. Basically, I'm going to be throwing like thousands of calls per second at OpenSIPS, and we are going to find the point where it would stop properly responding with the old code, like 1.11. Then we will switch over to async and see how well we do. So, I'm going to be I'm not going to be running with the make install effects of commands. We're just running into the root code directory, and let's generate a stock script. So we run make many config. I'm probably a bit fast. Generate script residential, and let's configure it a bit. We'll skip TLS for certificate errors and stuff, and we can enable authentication and dialog. That's basically what we're going to be working with. So let's rename it. Let's call it async. So, oops. Yeah, we're just going to be logging at output. What else? Skip. This is. Oh yeah, here we need to skip authentication, because we're going to be running some zip pp scripts, and yeah, it gets rough. So, yeah, basically, it should work. I also have a small startup script we can use. We're just going to be using 2 gigs of memory, because with so many dialogues and transactions, it's just better to be on the safe side. We can monitor it later. So, yeah, just memory, right. Let's fire it up. Oh, nice. What did we do? Module path. So we're working with locally compiled modules. Some database URL. URI module. Oh. Notice they're not sync. But they're right. Okay, so it seems the URI module doesn't have URL. We'll take care of it. Let's just throw it in here. Okay. Looks okay. So we just started. Like what? 8 processes? Yeah, like 8 children. Great. So let's see our. So we now have the central part up and running. Let's fire up the servers. Also, I have some little custom script to save some time. This one's listening on 750 and 760. Okay. So now all we need to do is fire up the UAC. See if we can get a dialog working. Start it in client mode, from, to, and 1 and 1. This is CPS and max calls. Okay, we just want 1 call. You'll often see me type G. This is an alias for just viewing the log. Yeah. Okay, so how much will this run for? Let's stop it. Oh, 15 seconds. Great, so we're going to have 15-second dialogues. Let's copy the script, because we're going to need it later in this state. Fraud. Let's call it fraud. Okay, and now we have the clients, the receiving clients, central part, and we need the big and slow SQL database that will, put a big problem in our platform with all the queries and the need to scale with, costful blocking I/O operations. So how do we simulate that? So right before we relay the invite, let's just throw in a nasty query. So right here, let's just do it for invites only. And we need the module as well. Also, throw in the DB-URL. Great. And let's run a select sleep. So let's, I think this is too much. Let's sleep 50 milliseconds. So this is a reasonable assumption, right? We assume that some platform operation we need to do, whether if it's a query on a super big database or external script, will run for 50 milliseconds. So what does that mean? It means that one children is able to run like, 20 requests per second at most, at best. So since we have 4 UDP receivers, we will only be able to do, 80, but we want to get to 2,000. So we need 100 children. Okay, that's how we do it in the old way. Okay, let's restart it. Looks good. As expected. Let's just shut it down. So I'm going to be also opening up a watch console, which will, it's quite tough to work with these small, with a touchpad. Yeah. Good. So, the point where OpenSIPS will not be able to handle any more the incoming traffic is where UDP queue starts piling up, right? So we'll do just that. We'll just, let's set it to like 1 million total calls, just to be on the safe side. And keep firing it. Oh, this is ugly. I guess it works. Probably like this. Okay, so let's just keep adding like 10. By the way, until we go further, please note that it's important before such stress tests on MySQL, to consider the max number of connections, right? Because maybe it will start, complaining. So I've just set up here max connections 5K. For the MySQL daemon, also restarted it. So OpenSIPS seems to be handling, or the old OpenSIPS, because you can definitely use 2.1 in its old behavior without any problems. Seems to be behaving quite well. Let's keep adding up 50 millisecond queries. After all, we have 100 children, right? So nothing should be stacking up. You can see the UDP here. Yeah, it's clean queue. So we're up to 800, 900, whatever. Oops. You see all these spikes starting to form up. Let's check out the logs for some errors. Also, we could skip this. You see the default script, it's quite filling up the logs, but we can check out the top. So how does it look like? So right now we're at 1500. It's quite well. Let's go up to like 1800. See how the watch console looks like. Oops, starting to pile up. But still manages to process like everything that arrives, like chunks of 1 megabyte, starting to add up. This is also nice to note the efficiency of OpenSIPS, right? Because there is a theoretical 2K maximum which can be achieved, and it also works well, like 1850, so that's like very small. It goes to show the small overhead of the script. Right, so in this state, at 1850 already it's starting to crack up. So we need to add even more processes, and it gets worse and worse. Okay, it's time for 2.1 async to come to the rescue. So I'm going to use the async statement to throw us in a resume route. I hate this small console. And let's call it sleep done. And basically our script will break right here. So right after the async transaction is created, it's already up, but nevertheless. And let's go to create the sleep done. See what we need to copy paste. Relay. Seems pretty important. Okay, we can. Okay. Also note that before using the async, we need to fine-tune the max async connections. And what this does is control the number of connections that a single worker will open to the backend. Because after all, or maybe not with all backends, but at least with MySQL, it has to open a new connection for every query it throws at it. So we're going to say that, okay, each process can open like 4K. And we're not forking 100 right now. We're only forking the number of cores we have, since it will be a CPU-intensive type of job. So I have a quad core, so we're going with 8. Looks good. What happened? No, I know what's happening. It's the dialog process is dumping all those dialogues into the database since we killed it. Yeah, I should. We could disable that. Yeah, let's just, since it's done on a separate timer anyway, it doesn't affect our workers. Okay, so we just started on the asynchronous code, and let's see how it behaves. Okay, first calls are starting to be up. No errors. Good. Let's see how it behaves now. Up to 1K. By the way, I think UDP retransmission is default. Okay. Let's just go up to 2K. You can see that there is absolutely no spike in the receive queue. Everything is just smoothly processed as soon as it arrives. Since you can see these 8 workers burning CPU like hell. They're 8, but great. Yeah. So looks pretty well. Why not see how much we can go further? So note that the more we increase this, the calls per second, the more connections each one of them fires up with MySQL at the same time. So 3K. Okay. I don't quite remember where I got into my tests. Any errors in the logs? Let's go for errors. Oh. Looks clean. And UDP queue still basically flawless. And yeah, getting to the top of our usage. It's 50. It's like 50 CPU, 50%. You can also see time spent in locking the system time here. So added up, it's like almost 70% pushing my laptop. Okay, 3K. Let's try with 350 and we can go further. Yeah. Oh, we run out of memory. I was just going to check that. So, yeah, we need more than 2G, which is quite okay, right? Okay, so I think this is enough to prove the initial part of the async demonstration. If I may ask Razvan how much time is left on this one. It's like
15 minutes.
15 minutes. So we could do like some register authentication with async, or maybe some HTTP, or maybe I could. What do you guys say?
I have a question.
Yeah.
So you're saying that using the async module, essentially every DB query is starting up a new connection, right?
There is a pool of connections, so it doesn't really do the SYN, you know.
Okay, so
yeah.
it is doing connection pooling internally.
Yeah.
Okay.
I have a question.
Yes.
You said that every time you use async module call, you have to split and give a function, a routing part of the code to handle the callback of the module.
Breaks the script. Yes.
There is no way to avoid this kind of behavior, because in this way, at the programming level, we are constrained every time to break the code.
To break the code, yes, that's what I said.
Forth and back
Yeah.
from
Yep.
functions, and if there will be in future a way to come back and be able that the callback function come back the execution exactly and the place where the script has stopped, so we can avoid this continued breaking, because in a quite complex script can be a lot of async operations to be done.
Definitely. So that's what I said in the slides. This may be, or definitely can be seen as a disadvantage. About what you were saying, for us to basically break the AST, it's in compiler terminology, to break the AST ourselves and detect which parts should go. From a strict theoretical point of view, definitely seems doable, but there are a lot of implications. For example, we need to determine what variables to be saved. Some sort of, we just listed a whole lots of problems that could arise if we are to break the script ourselves and identify what goes after async and how it should be run. For example, I don't know, it's a bit hard to give you something on the spot, but we definitely have it on our minds. Yeah.
Actually, this was the first approach on the asynchronous operation, because it was let's call it truth. It was the simplest approach, because we had there was no need actually to handle, let's say, all the implications from the script perspective. So by using a completely different route, then we can simply ignore the problems resulting from resuming the script itself from the same point. So otherwise, you have to save the stack of everything in the execution of the script, which is, let's say, the script part is not ready for that. So the scripting engine is obviously doesn't support.
Yeah.
So that would be probably step number 2, actually, to be able to hide everything from the script. So first we said, okay, let's have the mechanism, even if it's not so straightforward to use it from the script. And then to make also scripting nicer, but that would be step 2, and to implement a mechanism to be able to, let's say, save the state of the script execution and to then to be able to resume it from the same point further. So that's the missing part.
Yes, but at this point, maybe I think it's better to don't implement it at all. Because if we start to use this kind of way of coding, we have to change completely our way of scripting, make our script every query and every operation that needs async and after if you implement this, is a big mess to come back or maybe to change,
Definitely.
go back to use the old method. So maybe it's better don't implement it at all and start using it this way, and that's all.
For example, right now, using this approach, it's very clear at the level when you do an asynchronous operation and when not. If you don't have any kind of visibility between the two operations, then you will never know exactly, if the function you are doing hides behind an asynchronous operation or you may not have the feeling of what exactly you are doing. But how to say, at the end, maybe something kind of an option how you want to have.
Okay.
I would just say that we would, if we were to implement the AST splitting and stuff, the script would still have the async statement, right? Only that the script writer simply does not care anymore. You just write async and write your stuff right afterwards. It's not complicated at all. It just simplifies scripting quite a lot without any downsides. Yeah. So if we knew how to do it, we would definitely would have done it up too far. Yeah, definitely.
Okay, thank you.
Any more questions?
So just following up on that, I mean, you could quite simply do the async and then make a directive to a route right after it, which is the same route that you want the async to go to at whenever it finishes. So from your perspective, I understand you're saying you don't want to keep regurgitating the same code inside the same different routes.
Exactly. But we start to use this way of coding, and that's all.
But it's quite simply all you have to do is write your async statement, and underneath it, just redirect to the same route that the async statement is, and now you've got the same code inside the route.
Yes.
So that's an easy way to do it.
Yeah, sometimes it's not just as easy as copy paste. Maybe you have some variables that you had defined above the async, and all of a sudden they are not preserved anymore during the jump. So that's why I was saying.
And in this way, because you said one of the problems is to know what should be preserved and what should be not preserved before and after the code. But in this way, how we can know what now is preserved and what is not preserved?
That is written on the website. Okay. If we go to...
If it's documented...
Yeah, it's definitely documented here on the asynchronous statements. Preserved and ignored. Just check it out. It's in the root manual. Yes.
Okay.
Yeah.
Thank you.
So ADP variables are preserved?
Yes, because they're attached to the transaction.
You said problem.
Yeah, but maybe some use variables. It's like we can't just tell everybody if you use async, don't use vars. Yeah. We need to come up with a way to handle that before we fix it. Definitely, that would be one of the main features of 3.1, if anything else. Okay, so any more questions before moving on to fraud detection stuff? Okay. Oops. What happened to you? It's still firing up. Oh, ran out of memory. Oh, right. We forgot about him. Poor guy was just burning up. 100%. Okay. Yeah, just a general advice. just know straight from the beginning that whenever it gets close to max memory usage, there's going to be all sorts of undefined behavior, and while we do our best to write code that properly handles it, it's not that easy because we have the custom